we've shown that you can use partial derivatives to find implicit derivatives if you have one variable as a function of the other. But what if we have the case where one variable is a function of all of the other variables, not just one variable, but maybe it's a function of two separate variables? Well, what we find is it's actually pretty much the same process. If I have some function of two variables and I have some sort of equation that can be written in a way where I move all those variables to one side and let the other side equal to zero, well then I can find the partial derivatives by I can find the implicit derivatives rather by using the partials exactly the same way we did when it was a derivative with respect to a single variable. I can find those partials by saying, all right, partial of z with respect to x is the partial of this function in x divided by the partial of this function in z, and with a negative attached. So let's go ahead and do an example and just show the process, the algorithm. So kicking off here, if I say, if I have this function, or this equation, I need something like this. So the first thing I need to do is get everything on one side. And now that I've done that, this is my function. Then I need to get, let's go ahead and just get all the partials here. The partial with respect to x is 2x. There's no x's there, so it's just 2x. The partial with respect to y, 0 looks like 2z and then 0. The partial with respect to z, however, 0, 2y, 2z. So now I have each of these partials, so I can fill out these pieces. So grabbing another color here, I can say that the partial of z with respect to x so I take this divided by that, so I get negative 2x plus 2z. And similarly with the partial of z with respect to y, I get negative 2z and that's really all there is to it.